Hello everyone, this is the Mining Geologist, and I am back again with another very exciting and very informative tutorial. Before I dive into the tutorial, I want to say I'm really sorry for not being active in the past 2 months. They've been crazy months for me in terms of personal stuff and work-related things, and I want to thank everyone who reached out to me to see if I'm okay or not, and everyone who told me that they missed my tutorials. So I'm back again, and I have plenty of things to share with you, so make sure to subscribe if you're not subscribed. And there's nothing better than starting this new tutorial series with my favorite tool, Micromine. And let's continue where we stopped, in which I showed you like we're getting started with Python in Micromine and showing you how to automate things inside Micromine and how powerful is the combination between this amazing scripting language and this amazing tool, Micromine. So in the past video, in which we used Python with Micromine, I've showed you like basic, file manipulation in Python, how to like create a file, how to like append data, how to see how many records you have inside that specific file, how to like add things to that file and visualize that. So if these kind of things are what you're looking for, you can go and check the previous tutorial, and it should appear somewhere in here. You can go and check that out. So in this tutorial, I want to touch more on the block models. So how can you actually access the data inside a block model, in a Pythonic way? So I know that everything here, like in Micromine, makes everything easy. So if you click on this block, you'll have all the different informations that you're looking for. You can apply filters to filter out, let's say, a specific domain or like a specific grade or whatever you want, or maybe blocks at certain elevation. You can do that easily in Micromine. That's basic stuff. But we're going to do that in Python, and some of you might be asking now, if that's easy to do in Micromine, why would I, you know, um, go into scripting language and, write a bunch of, lines of code and try to learn that language in the first place, and for some of you. So, and just to do like basic stuff, like accessing the information inside a block. Well, to answer your question is that even though that Micromine will give you almost everything that you need, like in terms of the different charts, the different stats that you wanna see, or anything that you can imagine, but everything have a limit. So there might be this case where I don't know, like there's some new type of charts to look at specific data that will give you like a good information on a specific thing, but that chart is just like was released like 2 weeks ago, and it's easy to do, and but it's not implemented in Micromine yet, and you want to try that, and you want to explore how that works with your own data or with your own block models. You can do that in Python. Another thing is you might uh, like want to generate like 1,000, I don't know, like 1,000 chart, and you want to do that automatically. So you don't want to go and generate the first one and then go to the second one and so on. You want to do that in an automated way. So what you can do is you can create a script that does that for you, and plenty of other things. We can get to them while we're working, so I don't want to waste your time. So to get into scripting in Micromine, all you have to do is to go to the script menu, and then let me go and click on open script editor, and I'm going to have the latest script that I've been using. So now this is the script that we're going to use today, and I don't want to like write things as we go, because this tutorial is going to be like an hour for something really simple. So I already have this, but I'm gonna go through this line by line and explain how I got there and what kind of things that you can use or you can do with that specific thing. So I have the block model here, which is a data set that comes with Micromine, I believe. And this block model is the Raven block model, and you can see the IDW here, which means that the estimation method was the IDW. So we don't care about that. It's more like, getting access to the information using Python and try to manipulate that and create, charts out of the information. Even the charts that we're going to create are meaningless, but it gives you an idea how to use the data using Python. And that's the main reason we're doing this. So we have the block model in here, and let's go and edit form. And you can see this is the name of the block model, and this is where it is stored. So this is the path for that block model. Okay, so why do we need that? Because let's go to the different libraries that we're going to use for this one. So I'm now assuming that you know the basics of Python, but you don't know how to use the different methods related to Micromine, like to load a block model, to manipulate the block model, to access information inside a block model. I'm gonna assume that these are the things that you don't know, and uh, and I'm going to assume you don't know your way and what kind of things that you can do. And this is what this tutorial is about, because I'm not going to cover the basics of Python. So these are libraries that we're going to use. So basically in Python, you say, for example, you want to import this library NumPy that we talked about this in the past. It's numeric Python. Use this one for like numeric calculation, linear algebra, matrices, and all of that kind of things. And when you say as NP, it means that we're not going to use the word NumPy whenever we want to use this library. We're going to use just NP. So that's like a shortcut. We're creating a shortcut, and you can name this whatever you want. You can name it like XZ or whatever you want. But the common thing that everyone is using is NumPy, or I mean like NP. So import NumPy as NP. We have pandas. Pandas, you can think of this as if you have like an Excel sheet. You can do anything that you can do with Excel. So you can combine two columns into a different one. You can filter certain values in a specific column. You can sort values. You can do all sort of manipulations that you can do in Excel, but this is what pandas is for. Matplotlib, we're not going to use this one, but you can use it. I just said it there, so we know that we can use whatever plotting library. Matplotlib is to plot charts and like histogram, scatter plot, whatever you want. And I believe you can do like a 3D also, but it's a very basic one. And another one is the Plotly, and we have like Plotly Express. It's a simple one to use, but the graphics in Plotly, I like it because it's better than Matplotlib, to be honest. So I use Plotly when I want to plot like a histogram or anything like that. And manipulating Plotly, you will see later on, it's really easy. So let's get rid of Matplotlib, but if you want to use that, you can import that if you want. So now to see if the script runs, let me go and run this, and you can see the script run successfully, but nothing happened. We just made sure that we have these libraries installed. If you want to install them, you can just Google that, and it's as easy as writing pip install numpy, for example, pip install pandas in the command prompt, and you'll have all these libraries. And by the way, you need to install Python in order to be able to do these. Yeah, one quick thing I want to mention is that it depends on the version of Micromine that you have. Some Python, version might not be supported. Like for example, if you get an error that says the Python version of Micromine is 3.8 or something like that, then make sure to downgrade or to upgrade your Python version to that version. So just install the Python, let's say 3.10, and install 3.8 or you can install both of them, but that's going to be a little bit messy because you need to do some geeky stuff to make it to make Micromine just works with that 3.8, and you can work on different scripts with the recent version uh, of Python. Just like that quick note, you might it's a problem that you might face when you try to use this one, and that's what I faced, but it was very simple to fix. And of course, I knew how to fix it because of the great support from Micromine. They helped me, they guided me through this, and they helped me, and they told me that the Python version is the problem. Anyway, so now the first thing that we want to do is we want to create a variable in which we are going to store the path to the block model that we have. And this is what it is all about. So we have a variable called block model file name, or maybe like block model file, or you can call it whatever you name. So basically in this variable, we're storing the path to our block model, okay? So if you're going to get some like crazy results, so for example, you go to to the first record and the grade value is supposed to be like, I don't know, like 5, but when you look at your script and it's 10, then trust me, you're looking at the different block models. So this is really important here. So to get this one, it's really easy. You go right click edit form, and you can see this is the name of the block model, but we need the full path. So you go and copy this one, add a /, and you go and pick that obm raven.idw or so .dat, and you put that in the block model file name, and you're ready to go. Now, this is just for the path. We didn't now actually create a block model or imported a block model. This is a file path, so we don't want to like insert the full file path when we want to open the block model. We want to just use this block model file name, which stores the path to the block model file. Okay, so the next thing is we want to create some variables, which are the x field, y field, and z field. We can do this like, for example, x field equal to east, y field equal to y field equal to north, and z field equal to RL. We can do that, but that's going to be like 3 more lines, or we can do that this way. So x field, y field, z field, these are 3 variables, and you can just do like east, north, and RL. Sorry for that. So now the thing is, it's not going to be always east, north, and RL. So you might have something different, or you change that. But by default in Micromine, it's east, north, and RL. But I don't know, like somehow you've changed that, or you have something different, you can put the X, Y, Z fields, like X maybe here, Y, and Z, and so on. So if you want to see what is the name for that, you can go right click and choose open file. And these are all the different fields inside that block model. You can see that the X is east, the Y is north, and RL is actually, the elevation is RL. So we're good to go there. Now the next thing is we are going to create a block model instance. We use that by mmpy micromine python block model. This is the method or the thing that we can use to create a block model instance. Now when we are going to open a block model, it needs to be stored inside this instance. So just keep this in your mind. So instead of using mmpy.blockModel and you pass in like dot something else, what we want to do is store that in a variable that's called block model. So it's easy later on just to say like block model dot open, and instead of like passing the full thing in here. Okay, now how do I know that in order to create a block model instance, I need to use this one? So some of you might ask like, maybe if I want to look at NumPy, I can go and Google that, and I have like a documentation for NumPy, but what about these? Then for that, it's actually inside Micromine itself. You can see that we have mmpy reference So you go here and you have all the different methods that you can use inside Micromine. So for block model, you'll find them in the beginning. This is block model, close block model, copy, add a block, and you can see that the method is very descriptive. So what do you think that block model dot add block is going to do? So if you are, if you want to do something specific, all you have to do is to click at the script editor help and go and try to find whatever thing that you want. And that's how I did it myself. I was not like familiar with the different Micromine like methods and things that you can do in Python, but I was looking like, how do I know the record count of a block model? So like how many blocks in my block model? Well, I just go to here and look, and you can see that we have that's for the file. For the block model, you can see like block model dot records count, and it's easy. It's going to give you how many blocks that you have. It's easy as that. So let's continue. Now, the next line here that I have is to open the block model. So we have the block model instance. We pass in this new method, which is block model.open. The block model.open takes the block model file name, it takes the path for our block model. I can use this directly, so I pass in the full path in here without creating all of these. But now imagine if I pass this in here and also pass in the east, north, y in here. So it might be like a very long line, and I might need to do something like this in order to be able to use this. But that's why I like to store things in variable that are easy to remember, like block model file name is the path, or maybe I can call this even better, like block model path. And I pass in the path in here, the x field, y field, and z field. And now I've opened that specific block model, okay? Now, there are a few things. So for example, if I say records count, it's block model. I use that block model that I've imported, that I've just opened, and I say record count. So how many blocks do I have in there? So now let's go and print that out. So if I go print dot records count, and if I run this, and you can see that I have like 178,414. So if I go down, you can see that's the exact number I have. So some of you might be asking, why do I need to know the records count, or how many blocks? So you need that for like if you want to loop through all the different blocks. Maybe you want to check something specific in each of these blocks, so you can loop through that. And maybe you want to extract or filter out things, or maybe you want to do some sort of a calculation by looping through that through the full block. So instead of just saying, for example, for I in range 1000, and so you just go for I in range records count. Okay, I hope that it's not like Chinese for some of you who are not familiar with Python, but if it's new for you, please let me know in the comments below. If you want like maybe a tutorial on the basics of Python, even though that this channel is more like for like geoscience, geology, mining engineering, but I'm happy to make a video about the basics of Python. Okay, so you can see now we have the records in here, the number of blocks stored in that records count that we will need later on. Okay, so let's get rid of this one. Now, I'm gonna be creating like uh, you know, a dictionary here. I hope you guys know what is a dictionary in Python. It's a dictionary is like as if you have like columns and rows. So you have like, for example, you have the key and the value. So for example, the key could be X, and let me show you how that looks like. Maybe I can have like this one, X, and X is equal to a list. Okay, this could be like 1, 2, 3, 4, and so on. The next thing could be Y. So you can think of this one as like I don't know, like a column. I mean like a table, and I can pass in some Y coordinates in here. So maybe 2, 3, 4, and 5. The thing is that both of these needs to have the same length, okay? So you cannot have like one with the 3 elements in here and one with like 10 or so. So this is the structure of a dictionary. So you have the key and the values. It could be just one value like 1 or 2 or whatever, and you have as match keys or whatever. So this one also can be converted later on to a data frame, like a table, we see that. But now we have just an empty dictionary that we are going to append some data to that dictionary, okay? Now, what am I going to do is exactly that. So let me go and walk you through this for loop. Now, what I'm doing here is I'm saying for I in range block model structure field count. Now, what the block model structure field count does, it's basically, now you can see that records count, it's gonna give me, so if you look at the block model as if it is like an Excel sheet, it's basically a bunch of rows and columns, okay? If you use the block model records count, it's gonna give you how many rows, so that's how many blocks do you have. But if you use block model structure field count, this is going to give you how many fields you have. So in terms of block modeling, it's how many attributes do you have. So you have the X, North, RL, East. This is the size of the block. You have the grades, you have the domains, and so on. This is going to loop through the different fields that you have. So the first one is going to be East, the second one is going to be North, and then RL, and so on, okay? Then what am I going to do? This is, I'm going to loop through these, through all the columns, okay? Then I have a list called value here, an empty list. Again, a list is just, you know, a list of, could be a list of numbers, strings, floats, or whatever you can. So it could be like this one, and hello. This is a string here, like hello, for example, so on. So a list, you can store a list of values. But in our case now it's going to be empty, and we're going to append some data to that list, okay? So then we do is inside that loop, we're going to loop through a different thing. So we have a for loop in here. Now for I in here, and for G in here, for G in range record count plus 1. So we're going to loop in this one through the different fields, and this one we're going to loop through the different rows. And why we do that, we're going to do the same thing that I was telling you about. So you can see that we have value append. So we are going to append everything that we have in here to the values. So what are we going to append? So we're going to go through the different blocks in here. So we're going to the first one, the second one, and so on until we are plus 1. Why do we have plus 1 in here? Because, you know, indexes starts from 0. So we have 0, 1. Okay, so it's going to end just like here. We add 1 to access the last element in there. I hope that's clear. And by the way, if there's something not clear, that's why they have a command section, and make sure to leave a command there, and I will be happy to answer all of your questions. Okay, so now we append this value, which is exactly this. So what we do is we say block model get str block value, and it takes the I, which is the field index, the field index. So now, for example, when we're looping through this one, we're going to start here, and then we're going to loop through all the different values in the blocks. So it's going to fix the East and go 1, 2, 3, 4, 5, and so on. So okay, so now in I here, in the first iteration of the first loop, we're going to have a fixed I, which is the East. So this one, what it's going to give us, it's going to append the values in the East column. It's going to append them to this list, the value. And for G in here, this is going to be the different values inside this specific column, so the different rows. Okay, so we're appending that in here, and then when this loop is finished, what we do is we say that to this field we append By the way, here in get str, this one you can have also get num in here, which means like if the value is, I mean, if the column is numeric, you need to use that one. But if the column is, have some characters, like maybe this one, for example, in which like the domain, you can see that we have like string values, so we use str. But what I've noticed is that if you use num, for example, and when you look through the domain field, which contains some string values, you will have like 0 value. So it's going to be 0, which is not what we want. But if you use str, what it's going to do is you will still have access to the numeric values, but they're going to be not numeric, not integer or floats, but they're going to be string. So it's going to be, it's true that when you print that, it's going to be 5, for example, but it's going to be a string, not a float. And we'll get how to fix that later on. So make sure to use str in most of the cases, especially if you have columns that contain some string values. Okay, now the last line in here is basically like I've mentioned, we are going to get the field name, which is this one, which is when we iterate through the I. For example, we are in the first one, let's say in the east. So we're gonna get the east here. So it's gonna, when the first iteration is gonna end, it's gonna be like this. We're gonna have east in here. Sorry for that. It's east. We're gonna have that string like that, and it's gonna be equal to what? It's gonna be equal to all the values that we've been looping through. So it's gonna be equal to a list of all of the elements in here. Then what it's going to do is gonna move to the next one, which is north, and then it's going to append all the values of the north, and then at the end in here it's gonna say comma north is equal to all the different values, okay? But we're doing that automatically, okay? So why are we doing all of this? We're doing all of this because later on, what we want is to store this as a data frame. As a data frame, like I mentioned, pandas data frames are as if you have like an Excel sheet. You can manipulate that, like you can filter columns, you can multiply one column by the other, you can do different stats, you can I don't know, like whatever you want. And the good thing about pandas data frames, they are used by a lot of other libraries. So even if you wanna if you see someone like using some machine learning models inside Micromine, it's not that Micromine have like a machine learning module or something like that. They're using scripting. They turn the block models into data frames like we've done right now. It's really important. And then what you can do, you can search for libraries for machine learning, for example, and all you have to do now, you got that data frame, you get the machine learning module or whatever you want, and you can use that to train it for a specific thing, or maybe to generate some results, some crazy result that you have in your mind. And if you got something like that, I would love to hear that from you, and you can share that with us and we can showcase it here on the channel or on my LinkedIn page or Facebook maybe. So so we have the data frame now. So before we, and yeah, so just one thing, a data frame is we just go pd.dataframe and the data is equal to a dictionary, which is a dictionary like I told you in the beginning. A dictionary is somehow like like you saw, x is equal to a list of value, y is equal to a list of value. We can compare that to a table, and we turn that into a real table by using data frames and pandas data frames. So now we have a data frame of the different block models, like something like this. Let me just get rid of that last line to show you why I've added in the first place. So let me go and print df. It's not going to print everything in the data frame, just a little bit of that data frame, so to give you an idea. So let's go and print the df, and let's wait for that. It's running. And you can see now that we have some sort of a table. We have east, north, and we have all the different columns in here. And then we have like sector 6 and sector 8 and whatever is that we have in here. So now we were able to convert that block model into a data frame. Now we can do all the amazing stuff that you can think of. So I'm gonna just show you some really basic things that can be done, but I'm looking forward to see some crazy things that some crazy ideas that you have that you can do with this data frame, and what kind of things you want to see maybe in the next tutorial, or if it's something short that you want me to try, I'll make like a quick video and share that on my LinkedIn page. And I'll try to make something crazy myself and try to share that, maybe just the results on LinkedIn, because when I say crazy, it's going to be a little bit complicated in terms of, programming. And I don't want everybody to be overwhelmed by this and think that it's really hard to learn, and because this is going to make things easy, not hard for you. Okay? So why I've added that last one, it's because I have this, when I said that the index starts from 0, you can see that I have this empty line in here. So what I'm saying with this one is I want to filter out this first line. I want to get rid of that without actually deleting it. So now if I add that part in there and I click on this one, you will notice that it's going to start from an index of 1, and we'll get rid of that empty line. You can see now that we got rid of that one, and we have a data frame that is similar, or it's a copy of our block model data. Okay, so let's just remove this one and move to the next thing. Now, here's what I want to do is just remember when I told you that I used the str block model value in here, and that it's going to take it's going to turn the numeric values here to string values. So you cannot, for example, say this one plus this one, because it's not reading them as if they are numbers, but as if they are characters. So we need to convert the numeric values back to numeric and leave everything that is non-convertible, like the string values in here, to the way they are. So that's exactly what we're doing here. We're creating a new data frame called dfnum. So that's the name that I came up with, but you can call this whatever you want. I'm really bad at naming things. Okay, what does this one takes? It takes the data frame, and we have a method here called apply. It's basically you will apply a function to all the data frame, or maybe you can apply a function to a specific column. All you have to do is to pass in the column name here, maybe east, for example, and it's going to apply that specific function to the east column. In our case, we want to apply this to the full data frame. So what is this function? It's basically another data frame related, or pandas related function. It's called pd to numeric, and I believe that everyone understood what that function does. It's basically going to turn the data frame, or when I say data frame, I mean like a table. When I say data frame, remember, it's just a table. It's not something complicated. So it's going to convert that data frame to numeric. But some of you might be thinking, what if we have this one? So 5, it's obvious going to be like 5, like a numeric 5. But what about the column domain? We have Raven LG, low grade. So could we actually convert that to a number, or to like something numeric? Of course we cannot, and that's why we have this error here. In case we have errors, we want to tell this function to ignore the errors. So if you're not able to convert that, just leave it as it is. And this is exactly what we want. Now, with this one, we have the new data frame that we're going to use, in which we have everything that is numeric, it's back to numeric, and everything that is a string or like character, like this one, it's going to be just character. Okay. Now, what are we going to do here? Sorry. We're creating a variable called domains, in which we are going to store all the different domains. You can see that we have Raven LG, that's for the low grade, and if you scroll down, you can see that we have a high grade domain in here. Basically, we don't have lithologies, I believe, in this block model. We have just domains that are based on the grades. So I think they are just 2 domains, so we don't have to worry about that. So what the domains is going to do now, you can see that right here, everything was related to block modeling and, how to access the block model and so on. But when we convert that to a data frame, you don't have to worry about Micromine anymore. You don't have to worry about the methods inside Micromine. Now, all you have to do is to Google a few things like how to convert a data frame to numeric, how to access only the unique values inside the data frame, and then you're going to think of this block model as if it is just an Excel sheet. And if you Google pandas data frames, you'll find like millions of blogs, YouTube videos, and so on talking about how to do that specific thing. And we don't forget, of course, Stack Overflow. So every single problem that you're going to face in programming, you're going to find a solution to that one in Stack Overflow. So we got the different domains in here. Let me go and show you how that looks like. If I go and click on print, I mean like say print, and I want to print the domains and click on run the script. And it might take a while depending on um, the um, the size of the block model. And you can see now for the domains, yeah, so I've changed this one, I forgot. So we're not using domains. So if I use, for example, I'll get back to this in a moment. So if I use the colon domain, which is this one here, and run it, you'll see that I have just a list of two values. Wait a moment. So you can see that I have Raven low grade and Raven high grade. So you can see that I have a list of two values. These are the two different domains that I have. But what if I just go back to what it was, which is the pre-class? This is the classification, and you can see that we have indicated and we have measured and inferred. So these are the classes that we have in the block model, and we can just call this maybe classes, but leave them as domain because I've used domain in here. So if I click on run this again, so the domains is going to contain a list of the different classes that I have, okay? So this to give you an idea. So if you pass in a data frame and a colon and say unique, it's going to give you the unique values inside that data frame. And we see in a moment why do we need the unique values. You can see that we have indicated, inferred, measured, and we have some empty space in here. You can see that it's there, it's not visible. But what that means, it means that we have some rows in which we don't have any information. So just keep that in your mind. So later on, when you get something empty, you know why it is empty. So let me get rid of this one and show you the last thing here, which is, so what I want to do is I'm creating like a temporary variable here called classes. You can call this whatever you want. So you can call this X, or you can call whatever you want. So for classes in domains, so for every element inside the domains, which are basically like 4 elements, ignoring this one, we're going to say just 3 elements. So indicated, inferred, and measured. So in the first run, it's going to be indicated. The second run is going to be inferred. The third one is going to be measured. Okay. For classes in domains, what I want to do, I want to print the class name, and so we don't want to print anything. So let me just remove this line. So we say class type is data frame lock, df data frame numeric again. What are we going to lock here? We're going to lock the pre-class. So we're going to create a data frame that's called class type, in which we are going to filter the whole data frame by just one single class, which is this one. It's going to be the first element, then it's going to be the second element, and then it's going to be the third element. So in the first run, classes is going to be equal to indicated, which means that we're going to have a data frame. The full data frame is going to be filtered, and we're going to have only where we have indicated in the pre-class column. So we got the idea. And then in the second iteration, it's going to give us everything that have just inferred and then measured and so on. Then what we do is we use the Plotly Express to plot a histogram. So for the histogram, the data is going to be the class type, which is the new data frame that we've created. And the title is going to be the same name as the class, so we know which class is that. And then the field to do the histogram, to do different bins, is the TFE. So that's the total FE, which is this one, which is our grade. Now let's go and run this and see how it looks like. Now this is supposed to create like three histogram charts for us automatically. And this is why you might need Python, is to create things automatically. Maybe you want to create like 1,000 chart, and you can see that you can do this with just one click. So this is the empty data, the part in which we don't have any classes. So if I go to here, you'll notice this is the END, it's the indicated, and you can see this is the histogram for the indicated, class. If I go to the second one, this is the inferred, and this is the histogram for the inferred data. And if I go to the last one, this is for the measured. And I know some of you might be thinking now, I'm going to code all of this just to display histogram, and I can do that in Micromine with just 2 clicks. It's not about the histogram, it's about automation. So if you have something tedious that you want to do, you can do that. Maybe you have an idea about combining 2 charts or something like that, you can do that with Python. Maybe there's this new thing that just came up, and Micromine does not support that yet, but you can do that. Maybe you're really into machine learning and you want to try things, machine learning maybe related to geoscience, or maybe you have something for optimization, new technique. You can also do that in Python. You manipulate the block model with data frame. You turn that into data frame, and then you manipulate the data frames. So you got the idea. It's not about the histograms. So let me go and command this out, for example, and show you something else. So maybe you want to have you want to see something in 3D. So what do we have here? We're creating a 3D scatter. We're using the data frame, that numeric data frame, but now we're locking it to a specific domain. So the domain needs to be equal to Raven low grade, and the X, Y, and Z, we just specify that. The files, the size of the different points is going to be based on the grade, and the color, we're going to use the classes for the color. So let me run this, and you will see that we can also see 3D points, not in Micromine, but using an external library, and there are plenty of them to do a lot of cool things. So maybe there's a new kind of charts that's not supported by Micromine, but you can do that in Python. So you can see that we have all the different classes in here. It might be a little bit, not running smoothly here because the size of the block model, but you can see now they're white because I'm zooming out and it's dense data, but if I zoom in, you can see the different colors in there. And what I can do also, the good thing with Plotly, so you can see that it is interactive. If I click on anything or hover, you get all the information like the class and so on. So let's go and hide the measured, for example, and hide the indicated. And you can see this is the inferred data, and you can see that they are far away probably from our drill holes. That's why the class is inferred, and you can see that we have all of these points. So that's one thing, and maybe I can go and command this out and go to the next thing here. These are just simple things, but the main thing here is to show you how powerful is the combination of Micromine and Python. So you just take the data, turn that into a data frame, and then you can manipulate that like the way you want. So it could be either visualization, or maybe you have new techniques like to implement, or to new kind of interpretation or new kind of analysis. You can do that. You can see now we have a scatter plot, and again, so this is the measured, the inferred, and the indicated. So I can always go and hide these, and the colors are based on the where is that, the pre-class. So we can change this to domain, for example, and you got the idea. So that's the thing. So that's how you do things in Micromine and Python. And this is just a starting point to show you what is possible. So later on, if I publish something really advanced, you know where you can start. So the first thing is you go to this one and look for the things that you want to do. So for example, if we go to this one and you can see that these are the things, these are the inputs. You can see that this one is the path of the block model find to open. So I believe that anyone can understand this. So the field name of the block X coordinate. So that's really easy. So you can go, and then if you go to here, you can see that block model file name. Sometimes if that's exactly what you want, just copy and you go here and maybe you want to paste that. So you go down here, like go down here and paste that, and you can change this maybe to the file that you have. These are the X, Y, and Z, and you can change that. And that's how you do it. Micromine makes your life really easy. That's it, guys. I don't want to make this like longer than this. I hope you enjoyed this tutorial. I'm looking forward for any comments, anything that you think or ideas that you think that you can do with this one, or maybe something that you want to see in the next tutorial. So that's how powerful it is, Micromine with Python. I hope this tutorial was informative, and see you in the next tutorial.
So you've been working long and hard for a while now, searching for a solution to a problem you can't solve. Geologically, well, my friend, just let me introduce you to this beloved institution. He'll help your mining skills evolve. 'Cause technologically speaking, he's the real